on angles and their measures.
I'm so bad. Yes, you will.
Okay, so this first little bit will be pretty much new. I don't think we did anything with this last year. Those of you that were in college algebra, I think you did actually do a little bit of this. But the rest of it after that pretty much is just review. So these first problems want us to convert from DMS to decimal. So that's the degrees, minutes, seconds to decimal. And so they're not hard, just honestly kind of annoying, like the problems themselves. But anyways, so we've got 35 degrees, 24 minutes. So if it's 1 tick mark, it's minutes. If there's 2 tick marks, it's seconds. And so just like the number of like minutes in an hour, there are also 60 minutes in a degree. Just like there's 60 seconds in a minute and 3,600 seconds in an hour, there's also 3,600 seconds in a degree. So when we're doing these conversions, we're trying to get it to decimal. Decimal means like I'm going to have 35 point something degrees is what that's telling me. So I've got 35 plus, and then this one we use this number here over 60 because it's minutes, so 24 over 60. And that's converted that to degrees for us. And then at this point, you might need your calculator to do these. Some of them are pretty easy, but some of them,
2 over 5.
But as a decimal would be what?
0.40.
Yep. So 35.4 degrees would be the answer to this one.
I'm really good at this.
I'm proud of you.
Yeah.
For 48 degrees, 30 minutes, 36 seconds. So we've got the 48 plus 30 minutes, so that's going to be 30 over 60, plus, this is 36 seconds, so 36 over 3,600. Now, some people convert seconds to minutes, then minutes to degrees. I would just do it this way. It's faster, but up to you. So somebody combine those and tell me what that's equal to.
Of course you are.
Hey.
Supporting the class.
Hmm?
Said supporting the class.
You cannot buy those.
Actually, I stole them from Shepherd.
I bought them. Nah, I didn't. It was
I got 48.51. I'm like Robin Hood.
I'm like Robin the junior class.
Now, depending on what the amount of seconds would come out to be, sometimes it's not going to come out to be this nice rounded 2 decimal answer. Technically, the first decimal is coming from your minutes, your second decimal is coming from your seconds. So if it has another decimal, like say just like one more, you can go ahead and put it. But anything more than that, I would say just round it up. But don't round this whole answer because that wouldn't be
So round
to the full.
to the 100.
Basically, yes. Rounded, 2 decimal places,
You're doing good.
essentially. Unless it tells you otherwise. Because sometimes this doesn't work out to be a nice even number like this one was. Like this was 0.1. But that doesn't always happen. Okay, so that's DMS to decimal. Now we're going to go the other way. Decimal to DMS.
What do you even use DMS for?
A lot of
But it's not.
a lot of the stuff for DMS is when you're doing like distances and like traveling, or like if you like look at, I'm not like this like expert on globes or anything, but like the latitude lines and longitude lines often have minutes and seconds with them. And then sometimes the book is just super extra and uses minutes and seconds unnecessarily, with like the rotation of a tire. Very unnecessary. So yeah, there are some problems I kind of just like skip over with that, but I'm like, I want you to know how to convert them in case it comes up, but it's not super common. So 6, 49.7 degrees. So the 49, obviously what we've seen in the first two problems, that is basically just the like whole number degree value that you have. So then your first decimal place is always going to be related to minutes. Your second one's going to be related to seconds. And so we've got 0.7. Now, instead of dividing, we're multiplying. So 0.7 times, essentially the conversion factor is 60 minutes in 1 degree. So I'm just writing more or less the reverse of what we had up there. You could just write 0.7 times 60. And so that ends up being 42. So my answer would be 49 degrees, 42 minutes for that one.
I thought you said the first decimal place was minutes.
It is.
I thought minutes had 2 slashes.
Seconds has 2.
There's a second slash.
Boom.
Ooh.
Okay. 8. 99 point. Ran away. 37 degrees.
It's almost
Okay, so when we're doing one like this, we have to first convert to minutes. Okay, so the 0.37 is going to be entirely multiplied by 60. So instead of me doing like the first decimal is this and then the second decimal is, seconds, I do the whole thing. If when I'm done finding how many minutes, there's a decimal on the minutes, I take that decimal and use that to get seconds. So 0.37 times 60 minutes. Somebody's going to have to tell me what that one is.
22.2.
So that's 22.2 minutes. So I'm going to take this 0.2 and I'm going to multiply it by 60 again to get the number of seconds that I'm going to have. So I've got 0.2 minutes times 60 seconds. And that should be, 12? So as I write my answer now, my answer is 99 degrees, 22 minutes, 12 seconds. All right, any questions on those? All right, the next stuff is dealing with conversions from basically radians to degrees. I don't even think that degrees to radians is in this section. Yeah, it's not. So I guess that comes later. So let's look at 20. 3 pi over 5. Now, what I'm also going to tell you is that some of these values, like number 18 that I skipped, is pi over 4. That's going to be a value you just know from your unit circle. You don't need to do the conversion on it. But if you forget them, whatever, you can do the conversion. So I'm going to go ahead and, obviously this one I don't just know this off the top of my head, so I'm going to do the conversion. So we set it up 3 pi over 5 like this. And then what is the conversion factor for radians to degrees?
180 over pi.
Yep, 180 over pi. So the pi's will cancel, and then obviously you probably could do this in your head, but you have a calculator in front of you, so Somebody quickly tell me what that's equal to.
108.
So that's 108 degrees.
That's what I thought. What?
You didn't decide to be smarter than me.
How?
You just do 720.
No, I didn't really want to know how. I was just saying.
I'm explaining it to you so that you can be smart as you one day. If you don't have a calculator.
Okay. Now, obviously, these instructions have told you that we're going from radians to degrees. But the next problem is they just tell you that it's 1.3. There's no pi on there. Okay? So, technically, if we were writing our answer and there's not a pi, we would want to write that there are radians. But basically, if there's not a degree symbol, you should assume it's radians, even if they don't put, whatever. Now, they included it in the instructions, so I'm sure that's why they didn't write it, but anyways. So, same thing, though. We end up with our times 180 over pi. Now, you just can't cancel the pi's, so you'd have to multiply that out that way. Somebody tell me what that one is. What?
74.
Is that it? Where is it? Okay.
I
So if
I thought I was wrong.
I would say go to like 1 or 2 decimals on something like this, if it obviously the pi's there were not 2 pi's to cancel, so it was gonna have some sort of a decimal, I was pretty sure. But I don't know how I skipped that whole section of problems. Apparently, I just missed the degrees to radians problems. Apparently, I can't read. So we're gonna backtrack for just a second. 12, or no, not 12. We're gonna do 14 instead. 11.83 degrees, and we're going to radians. So these technically say convert DMS to radians because they could give it to you in minutes and seconds. I'm not super inclined to give you one that's in that, like, just because if you've already proven to me that you can do degrees, minutes, seconds, and convert that, I don't need you to also prove that you can then convert it to, like, radians or whatever. So this one we just flip it. It's pi over 180 because we want degrees to cancel. If they're whole numbers, so if this was just like 11, I would try to just like reduce this as much as possible or leave it as like 11 pi over 180. But since it has the decimal, you're probably just going to have to give me a decimal answer for your radians. And just make sure you write RAD for radians so that we know what units it's in.
0.206.
All right, questions on those? If in, say, like a word problem or something like that, you needed to convert your degrees to radians and it was in degrees, minutes, seconds, obviously we would just take what we have, like, say, these up here. So if we had this, like, 48.51, and then we would multiply by pi over 180 and turn it into radians that way. But like I said, I'm not intentionally giving you one like that. I'm just, explaining the process. Okay. The next stuff is to use the appropriate arc length formula to find the missing information. So I don't know if you remember from last year, but to find arc length, we use the formula S equals R theta. What does theta have to be?
A degree.
No. Radians. Okay, so if it doesn't give it to you in radians, you need to put it in there. I would say most people, when they miss these problems, that's what they set the whole problem up right, and then they forget to convert to radians to do the problem. We also did some area problems last year. I don't know if that comes up in this section or not. I don't see it. So, anyways, but we also had the area formulas last year using this. But these ones, they just want us to find arc length. So they're going to give you some portion of the information. They might give you arc length, they might give you radius, and they might give you, you know, your theta value. They're going to give you 2 of those 3 values, and you're solving for the other one. So 26, S is unknown, R is 1 centimeter, and theta is 70 radians. So notice they've specified that for you there with in words. So S equals 1 times 70. Obviously that one's easy. 70 centimeters. And make sure you put your units on these problems. S is equal to 2.5 centimeters. R is unknown. And theta is pi over 3. So if I have 2.5 equals R times pi over 3. Shepherd?
Sorry.
No. What's your favorite phrase in my math?
Keep change flip.
There you go.
I was
So,
going to sleep.
I was just saying it because you always like to say keep, change, flip. So we're going to multiply by 3, divide by pi. Somebody tell me what that's equal to.
Stop 4.
Why'd you say 4 then?
Because he said 4. I can't do it in my head.
2.4.
Yeah. 2.4 and centimeters. S is 4 inches. R is 7 inches, and theta is unknown. So I've got 4 equals 7 times theta. So theta is equal to 4 over 7. Because this doesn't have a pi, you need to write RAD for radians.
What is the arc length?
That.
So think about, I was gonna say, think about like a pizza. Your arc length is the, he basically said it, the crust of your pizza, the outer edge of your pizza. All right, now there was one other formula that you had, or that you should have had, that was a different version of the arc length formula, so that when you have something like 32, where S is unknown, R is 5 feet, and theta is 18 degrees, instead of having to convert to radians first, there's a formula that's just a modified version of the formula. I personally just convert first and then I plug it in, but the other version is S is equal to pi r theta over 180. So all they have done is they've taken my S equals r theta and they've multiplied it by my conversion factor of pi over 180. So it's really up to you if you want to memorize 2 formulas or you just want to convert first. But historically, like last year, all we did was convert first when we did these. So really up to you. But I'll use the formula on this one just because why not? So I've got pi times 5 times 18 over 180. Somebody can tell me what that is.
Half of pi. Yeah.
I got 1.57.
Yep. So, like I said, You can use this formula, you can use the original formula and convert first, but just make sure you pay attention. Theta has to be in radians, and so that was why we had to do this modification on this one.
Do we need to adjust our calculators for these?
No, that's only if we're doing a trig function.
Okay.
Cash's favorite question.
I love
Does it need to be in radian mode?
Anytime something's wrong with the calculator, so
All right, we're gonna do a couple word problem example things here. So find the perimeter of a 60-degree slice of a large 14-inch pizza. Now, anytime you are given the dimensions of a pizza and they tell you like a large pizza is 14 inches, okay, they mean the entirety of the pizza. That's not half the pizza, that's the diameter. So, what does that mean my radius is?
7 inches.
Yep, 7 inches. This is my theta here, is 60 degrees, but I'm going to need to convert it. You can either convert first or use the modified formula. Does anybody remember what 60 degrees is in radians?
pi.
Pi over 3. So I'm going to just use S equals R theta. Now, that's just to find now, I'm finding the perimeter of a slice. Okay, not the whole pizza. So, S equals 7 times pi over 3. So somebody tell me what the arc length of my pizza is. So 7.3 inches is the crust of my pizza. Okay. Now, I want the perimeter of the whole slice. So the perimeter is each side of the slice should be 7 inches.
Plus 14.
So 7 plus 7 plus 7.3. 21.3 inches is the perimeter of my whole slice of pizza. So when y'all eat pizza on Thursday,
Thursday you order pizza.
Oh,
for those that order pizza from the cafeteria,
Hey, could you tell me how many degrees this slice of pizza is?
be like, can you tell me how many slices were in this pizza? But they don't do them all even. That's why like Sam's and Costco, they have a pizza cutter that is set so that every slice is the same.
Okay, so this is the perimeter of like a cone.
Basically, yeah.
Stop.
Okay. 36. A 100-degree arc of a circle has a length of 7 centimeters. To the nearest centimeter, what is the radius of the circle? Okay, so S equals 7 centimeters. They said the arc of the circle's length is 7 centimeters, so that's our arc length. Theta is 100 degrees. So again, either you're going to need to use the modified formula or you're going to need to convert first. And then I'm trying to find the radius. So I'm just going to use the modified formula. So S equals pi times 7 times 100 divided by 180. I just realized I just put these numbers all in the wrong spot. Hold, please. I need to write the formula out first. S equals pi r theta over 180. There we go. Okay, now let me actually plug these in where they're supposed to be. So 7 equals pi times r times 100 over 180. So r equals 7 times 180 over 100 pi.
No, wait, hold on. I can do this. 40. No,
39. Just 40 in total.
this is 39.58.
Yeah,
This
so
is
you
right
got
on
it.
here.
So it's 40.
4.01.
Yeah, I got 4.0.
I was gonna say, I was expecting it to be more like 4.
Did you?
Did you, I was gonna say, did you divide by 10 or 100?
Divide by 100 pi.
Are you in radians or Why is that so? I don't know.
Alright. One more word
Stop.
problem, and then we will be done. Number 45. Kathy races on a bike with 13-inch radius wheels. When she is traveling at a speed of 44 feet per second, how many revolutions per minute are her wheels making? Okay, so a couple things that I noticed right off the bat is that my units are all over the place. Okay, because I've got up here, I've got 13-inch radius wheels, but then I've got revolutions per minute, and I've got 44 feet per second. So I've got units everywhere. Okay, so I need to be mindful of that. Another conversion that you need to be aware of that probably was not in your notes is that 1 radian is 1 radius of arc length. So the conversion factor is 2 pi radians over 1 revolution for when I'm dealing with revolutions. Okay, which is how many times essentially the wheel's going around. So the first thing I would probably deal with is converting my inches to feet, just so that that's taken care of. I'll deal with the seconds and minutes at the end in my conversion chart. So I've got 13 inches. 1 foot is 12 inches. So that's something like 1.08 feet, or it should be. And this is my radius. So now I'm going to use my big conversion T-chart thing and fill in all my information. So I'm going to start with I travel at 44 feet per second, so 44 feet in 1 second. 1 radian is 1 radius of arc length, so that means that this is my radius, so I'm going to have 1 radian and 1.08 feet, because that means my feet are going to cancel. Then, this other conversion that I gave you is that 2 pi radians is 1 revolution, so I'm going to flip that over and do 2 pi radians in 1 revolution. So essentially, I have taken care of getting rid of everything but revolutions, because I've canceled feet, I've canceled radians, so I'm down to revolutions. So I've taken care of that part. Now I've got 1 second, and I need to basically get that to minutes. So I've got 60 seconds in 1 minute. So feet canceled, radians canceled, and then seconds now cancel, and so the units that I'm left with are revolutions over minutes. So then now I just need to multiply across the top and then divide the stuff off the bottom. So I'll have 44 times 60 divided by, on the bottom, 1.08 times 2 pi, and that will give me my final answer in revolutions per minute.
Is it 15,358?
No.
Is it
Something's
wrong with my
calculator.
Yes.
The last one, you just needed to parentheses up.
I was going to say you probably needed parentheses.
6.4.
It should be 389. So in your calculator, you would need to do like 44 times 60, and then either use the fraction bar or use parentheses and do 1.08 times 2 pi if you're going to do it this way. If not, you need to put parentheses around this whole thing and then do like divided by.
Is it 389.05?
Yeah, and I just rounded it to 389, but because I think it said to the. Was that this problem? No, it was not. I was gonna say, was that the problem that said to the nearest centimeter? But this obviously isn't centimeters, so. All right, so you have a problem that's gonna be kind of like this. It's a what is it? It is a radial arm saw. So, anyways, people tend to struggle with it, but I want you to give it your best shot on that problem. Okay, it's very similar to this one in how you do it. But anyways, problems are 3, 7, 15, 21, 25, 29, 31, 35, and 47.